Okay, so today I'm going to post the video on working the test 4 I gave you problems, since I won't be having you guys in class for the rest of the semester most likely. This way you can check the work you did to see if you worked it correctly, and you guys give yourselves a pat on the back if you get it right. So, number one. So number one on your test asked us if we had a 78.23 gram flask, and that's the empty weight. We fill it up with pure water, and it weighed 593.63 grams. So this is our full, this is our empty. Now it asks, when the same flask is filled with concentrated sulfuric acid, it has a mass of 1,026.57 grams. What is the density of the acid? Okay, so first thing we need to do is we need to find the volume of the flask. Now, pure water, we assume to always weigh 1 gram per milliliter. That's its density. So in order to find the milliliters of the flask, we need to subtract the full weight from the empty weight, and that'll be equal to grams of water, which will in turn equal the milliliters of water. So 593.63 grams minus 78.23 is equal to 515.4 grams, or 515.4 milliliters. So that is the volume of the flask. Now the density, now if you remember our equation we learned, density is equal to mass over volume. So we're looking for density. This is what we're interested in. We are given the mass of the sulfuric acid, that's 1026 grams, and the volume we now have solved for. So to find the density of sulfuric acid, density is going to be equal to 1026.57 grams over 515.4 milliliters. And that comes out to be 1.992 grams per milliliter. That is your density of sulfuric acid. Problem 2 asked us to consider the reaction 2ICl3 plus 3H2O goes to form ICl plus HiO3 plus 5HCl. The question is asking us if we have 0.9 question is asking us, we have 0.98 grams of the H2O, and we have 1.35 grams of ICl3. How many moles of HCl can we produce? So the first thing we do is we need to find the limiting reactant. So in this case, the limiting reactant is going to be the ICl3, and it's pretty easy to determine without even solving, is because it's a 2-to-3 ratio, so you don't need a whole lot more water than the ICl3. But the mass of ICl3 is many, many times greater than the water. The mass for ICl3 is 233 grams per mole, and water is 18.02 grams. So if we were to go ahead and divide the grams we have by the molar mass for both species, we would find that ICl3 is going to be our limiting reactant. So now that we know that that's our limiting reactant, we can solve for how many moles of HCl we're going to get. So we do that by using dimensional analysis. So 1.35 grams of ICl3 we have 1 mole is equal to 233.25 grams. Now here is where our the stoichiometric ratio comes into play. So we have moles of ICl3 on top. So we need moles of ICl3 goes on the bottom here to every 5 mole of HCl. Now if we go through and look, we see that grams of ICl3 cancels out. We see that moles of ICl3 cancels out, and we're going to be left with moles of HCl. And when we multiply this through, we find out that we have 0.0145 moles of HCl. And that is your answer for number 2. Number 3 is a little more complex of a question. The question states we have phenol, which is C6H6O, and it gives us the mass as 94.11 grams per mole. And it undergoes complete combustion with excess oxygen, so we don't have to worry about limiting reactants here, to form water vapor and CO2. We collect the water vapor and we condense it and we cool it to 35 degrees Celsius, and we end up with 15.3 milliliters of water. And the density at 35 degrees is 0.994 grams per milliliter. So if we collect 15.3 grams, this question wants to know how many grams of phenol did we burn? So the first thing we can do is we need to balance this chemical equation. We don't know the ratios of all these species, what they are to one another. So we know how to do that. We learned that a long time ago. We're going to first set up an expression for each species. So in the case of carbon, it would be 6A is equal to D. For hydrogen, it would be 6A is equal to 2C. And for oxygen, it would be A plus 2B is equal to C plus 2D. So if we just arbitrarily go through and set A to 1, well, that would mean that D would equal 6. If A was 1, then C would equal 3. So now that we know A, D, and C, we can plug those into here and solve for B. And it turns out that B, sorry, I don't know why it keeps doing that. Turns out that B is equal to 7. Okay, so now that we have our balanced chemical equation, we can find out how many grams of phenol we burned. So we're going to need to use our density equation here. So if density is equal to mass over volume, we were given the density of H2O and we were given the volume of H2O. Well, if we want to find out how many moles of H2O we have, we need to find out how many grams we had. And we do that by multiplying volume times density to find the mass, which then we can find the grams. So we were told that we had 15.3 milliliters of H2O, and the density was 0.994 grams per milliliter. When we multiply that through, we find out that we have 15.21 grams of H2O. Now that we know how many grams of H2O we have, we can solve for how many grams of phenol. that we burned. So 15 grams of H2O, well, 1 mole of H2O is equal to 18.02 grams. We had 3 waters formed for every 1 phenol burned, and 1 mole of phenol was equal to 94.11 grams. If we multiply that through, we find we have 26.48 grams of phenol, and that is your answer for number 3. Number 4 asked us if we had to find the mass of nitrogen in a vessel that was 250 milliliters at 300 degrees Kelvin and with a pressure of 0.772 atmospheres. So if you remember the equation I taught you, PV equals nRT. Well, if you look at what the question gives you, we are given a pressure, we are given a volume, and we are given a temperature. If we are going to find the mass of the nitrogen in the cylinder, we need to know the number of molecules that are there. Well, R is a constant related to the pressure that we're using. So we just need to rewrite this equation to solve for N. So N would be equal to PV over RT, which is going to be equal to 0.722 atmospheres times, now we need to convert the volume to liters. So 250 milliliters is equal to 0.25 liters. R for atmosphere is 0.0821, and the temperature is 300 Kelvin. That turns out to be 7.3 times 10 to the negative third, and that is going to be moles of N2. So now that we have the moles of N2, we can find the grams easy enough. So 7.3 times 10 to the negative third moles of N2. 1 mole is equal to 28.02 grams. If we multiply that through, we are going to end up with 0.205 grams, which is equal to 205 milligrams. And that would be your answer for number 4. So I will post questions 5 through 8 on the next video.